So we're looking at simple probability and the probability of multiple events occurring. So we start out with 5 multiple choice questions, each with 4 possible answers. So that means the probability of choosing a correct answer is 1 out of 4. The probability of getting a not correct answer, also known as C prime, is 3/4. 3 wrong answers out of 4, 1 right answer out of 4. So what's the probability they get none of the questions correct? So 5 of the probabilities that none were correct. And so this would be 3/4, missing the first one, missing the second one, missing the third one, missing the fourth one, and missing the fifth one. Okay, so to determine that, I'm going to go to my handy dandy little calculator here, and I'm going to say 3 divided by 4 raised to the 5th power, because that's what we've done, and that's 0.003. I'm going to round that, and so this is approximately 0.003. Okay, doesn't matter the decimals you pick, but it's fairly close. Okay, the next one says, what's the probability of getting all the questions correct? So instead of 3/4, we're doing the probability they are correct. So it's 1/4, 1/4, 1/4, 1/4, 1/4. In other words, that's 1 divided by 4 to the 5th power, and that's 9.76 e to the negative 4. Okay, that's exponential notation. So I move this decimal 3 places to the left, and the 9/7 is going to make that fall as a 1 farther up. So that's 0.102030 is where that number would be. So that becomes, it would be 0.00097. 7 causes the 9 to round up, and that becomes a 1. Okay. The probability they get at least one of the questions wrong, and I've suggested this, anytime you read the phrase at least, you think 1 minus the complement of getting them all right. So this is going to be 1 minus the probability of getting all 5 right, which was this question, okay, which was this problem. So this is going to be 1 minus 0.001, which is equivalent to 0.999. Okay, so guessing 99.9% of the time, you're going to get at least one wrong. Now, there's a lot of ways of figuring this one, but with me, at least is the most common that makes the most sense. Okay, the next one says, what's the probability you get your first incorrect answer on the 4th question? So we're going to get 3 right, and then we're going to get 1 wrong. So this is going to look like 1/4 to the 3rd power for the 3 we got right times 3/4. So still a bunch of 4s, or 3 divided by 250. Sorry, this is the 4th power here. Whoops, clear that. So 1 divided by 4 raised to the 3rd power times 3 divided by 4, and that is 0.012. So this is approximately 0.012. Okay, 1.2%. Okay, now on our next one, we're making peanut butter M&Ms, and the company Master Foods that makes them says that they have 10% brown and red, 20% yellow, blue, and orange, and the rest are green. Well, 20, 20, 20 makes 60, 70, 80, that leaves 20% are green. And the very first question asks, what's the probability it's green? And I'm going to put 0.2, change everything to a decimal. The next question says, what's the probability it's a primary color, red, yellow, or blue? Red, yellow, or blue. Or means to add. And so we're going to add the red color, which is 0.1, plus the yellow color, which is 0.2, plus the blue color, which is also 0.2. So that's going to be 0.5. Then it asks, what is it? What's the probability it is not orange? Okay, the opposite of orange is not orange. Orange we saw was 20%. And so if we go 1 minus 0.2, that is 0.8. or you could have added up all the others and gotten 80%. It's all the same. Now this next one is very similar to the top. We've got a lot of things going on. We're picking 4 M&Ms in a row. What's the probability they're all blue? So I want 4 blue. So back up here, blue was 0.2. So this is going to be 0.2 times 0.2 times 0.2 times 0.2. Where 2 times 2 is 4, 8, 16 with 4 numbers behind the decimal. Notice I didn't put wavy lines here. These numbers are all correct. 0, 0, 1, 6. Okay, we multiply because it's probability of getting a blue and a blue and a blue. It's not or means add. It wasn't blue or blue or blue. It was blue and blue because we wanted to get blues. Okay, so here we go. None are green. The probability none are green. Well, green again is 20%. So the complement of green is 0.8. So this would be 0.8 times 0.8, 0.8 times 0.8. Okay, and off the top of my head, no, I don't know that number, but I can raise 0.8 to the 4, and that's 0.4096. 0.4096. Okay, then our next question is at least 1 is red. There it is, that at least again. So here I go. I'm going to use the complement. 1 minus the probability that none of them are red. Okay, none are red. Red was 10%. So this is going to be 1 minus 0.9 to the 4th power. This is not red. Not red. The complement of being red. And so 1 minus 0.9 to the 4th. We go 1 minus 0.9 raised 4. Sorry, I went blank there for a moment. It's 0.3439. Okay, 1 minus 0.9 to the 4th is 0.3439, or about 34.4%. Okay, here we go. Another one of these. The 4th one is the first one that is brown. The 4th one is the first one that is brown. So we want not brown, not brown, not brown. Oh, that one's brown. So brown, back up here, was 10%. So what is not brown? 90% of them, just like the previous question. 0.9, 0.9, 0.9, 0.1. 9 times 9 is 81. Times 9 is 723. Times 1 is still 723, but 4 numbers behind the decimal point, 0.0723. Okay. Then the last question says, after picking 10 M&Ms in a row, you still haven't picked a red one. So a friend that says you should have a better chance of getting a red candy on your next pick since you have yet to see one. True or false? And that's false. He is not correct. Okay. Because our N is so big, it's a huge number. Our sample size of M&Ms is just gigantic. The probability of each event does not change. It's theoretical. We do not expect it to change. Now, if we were to take a small sample, it might, but with this, it will not change. So there you go. That's the work from last week, and there's my video done. Thanks.